All right, today we have a 2013 Volkswagen Tiguan. This one is the 4Motion and it has got three problems, one of which was very simple. First thing she said is that it dies overnight and she had resorted to disconnecting the battery so that it doesn't give her a problem restarting in the morning. But even that doesn't seem to work anymore. Well, that one was a very simple issue. She just had a bad battery. The battery could not store charge and it was charging at just about 3 amps only, even from a low charge. So that one was easy. It has no parasitic draw. I checked the current. New battery solved that problem. Second problem it has is severely low power. So when you drive this, most of the time your foot is on the metal. It doesn't respond very well to sudden moves. In fact, when she's going to accelerate, when she's going long distance, she has to do a very long calculation and she can only overtake slow moving trucks. She can't overtake any other car. She is unable to go, I think, past 60 kilometers per hour most of the time. So we want to look at that today. And then the third problem she said is that the parking light, so let me put the key on. The parking light comes on, but it's not red. Right now it's red, but let me put the car on. So if I release the parking brake, so right now you can see the parking brake is completely disappeared, but she said it appears as a yellow sign with a cross on it, and then it drags the car behind so hard. The car really struggles moving when you have that condition. So we're going to look at that as well. Now the battery, I want us to go and look at the battery, and I want to show you a myth that a lot of people with these Euro cars have before we continue. Right, here we are under the hood, and I just want to talk a bit about the battery. Now this is a DIN battery that was installed in this car. People with Euro cars are always told that you must buy DIN batteries. I honestly do not know why people insist on buying DIN batteries, because DIN batteries are 2 to 3 times the price of a regular battery. And guys are told that if you do not put a DIN battery in your Euro car will not function correctly. Guys, that is BS. So what is DIN? DIN stands for Deutsches Institut für Normung, or German Institute for Standardization. DIN is a standardizing body, just like you have ISO. Guys, a DIN battery is simply a battery that has been standardized by the German Institute for Standardization. It has got nothing to do with the battery chemistry or the way the battery works. So if you're buying a DIN battery, all you're buying is a battery that has been standardized by the German Institute for Standardization. It does nothing else. Stop falling for this nonsense that you must buy a DIN battery. You're wasting your money. Just get the normal battery. As long as it's a good brand, like Amarin is a very good brand, it's going to last the same amount of time. You don't need a DIN battery. So let's tackle this low power issue that this car has. When you have an issue with low power, what do? Well, you start by looking at live data. So let's go to Odis, pull up live data for this car, and then we are going to see what direction we have for the low power issue. We are in Odis and we've just finished a system scan. Got a bunch of codes, but right now I'm interested in my engine. So let's right click here and we go to control module OBD and we read the DTCs. So got the current ones. These are the ones that are keeping the engine light on. Correction charger throttle valve pressure drop. Mass or volume airflow A circuit range performance. Turbo supercharger underboost. This is an interesting code. Now, I will tell you one thing. If you have a mass airflow code and you have an underboost code, I would suggest you deal with the boost first before you go to the mass airflow, because if you don't have enough air flowing through the turbo, you're going to have a range performance. And notice here, it is circuit range performance, not circuit fault. So, maybe is this here? System 2 reach at idle bank 1. I'm going to ignore the system voltage because we had issues with this battery, so that I will ignore. But this, and this, we have a boost problem in this car, a turbo issue. So let's go to our live data. Now I'll show you why I don't like using Otis for live data. Let's go back here to the diagnosis. We'll come here, right click, guided functions, and then measured values, reading measured values from engine. That's what your live data is called. Sometimes it allows you to pick, now this one, for example, you see it'll allow you to pick the measured value by name and by ID. But a lot of the times you'll just see the ID with no name here. That is why I suggest using an aftermarket scan tool to view the live data in these cars. But in this case, seems like we are good to go here. So let's pick some of these. Engine speed, coolant temperature. And Volkswagen repeat stuff a lot in their measured values. So look at this: engine speed, engine speed, engine speed, engine speed, engine speed. And yeah, they will show the same thing. So let's come here and filter. Let me go to fuel. I want the fuel rail pressure actual value, and I want the specified value. And then let's go to fuel trims. But fuel trims are called lambda in Volkswagen world. So you're going to see the lambda control value. That is a short-term fuel trim. The lambda adaptation value is a long-term, and there is at part load, and there is the other one here. This at part load will be when you're driving. This one is the one that's going to show up. I don't know why they have separated them. And then the actual lambda value. So this one you're going to see whether we have achieved a lambda of 1. And the lambda of 1 is 14 parts of air to 1 part of fuel. Then let's look at our turbo boost. No, it's not called boost. Let's go to pressure. Charge pressure, okay? So let's look at the charge air. First I want you to see the current value and the specified value. And then the mass airflow, air mass. All right, I think this will be good. So let me start the car. And then you need to come here and start update. Otherwise, it won't update. When you see this green slider keep going like this, it's updating. So right now we're at 800 RPM and we have a coolant temperature of 85. We are up to temperature. Air mass of 3.3 grams per second. Now this may seem high, but look at the idle speed. We are at 840, which is higher than normal. So I'm not going to worry too much about that. But look here, our lambda adaptation, which is our long term, is negative 5.2, and our lambda control, which is short term, is negative 3.52. Right now we're not running rich. Let me give it a bit of throttle. See there, I'm holding it at 2000 RPM. Our long term is still negative 5. Our short term has gone up. Interesting. Now charge pressure is in millibar. I don't like this value in millibar. I'm not used to looking at things in millibar, but all I know is there's specified and there's current, and Our specified is much lower than current, but the car is not moving. So these two mean nothing unless the car is moving. So we're going to look at what happens when the car moves. Fuel pressure looks good, sitting pretty at 40 bar, and in MPa that's just divided by 10, so it's 4 MPa. That's what it's supposed to be, and our specified and actual are close to each other, so I'm good with that. So far I'm not seeing anything here that's wrong. Let me go back to idle. Now we're idling. I don't see anything wrong here so far. We need to go on a test drive. So let me leave this live data as is and let's prepare for a test drive. Now I'm just sitting here and I noticed that my lambda control, which is my short term, it went way negative. It hit negative 25, but it stayed there for a short time, then it came back up. The other thing I noticed is that my mass airflow here went above 5 grams per second, yet my engine speed remained the same. I just want to see if it'll do the same. So let me give it a bit of throttle first. Okay, let it idle. Yeah, look at that short term. So it started going negative, then it came back up. I want to see if it will go negative again. There it goes. We got negative 9. So I don't know what's going on, but we definitely have a fuel trim issue, because if that goes too high, like how it went to negative 25, that's what we're going to get that code for, the rich condition. Are these related? I don't know. First I want to tackle that boost issue, so let's go for a test drive. Alright, I'm on this stretch of road and I'm driving, and let me just show you what happens when I put my foot to the floor. Alright, so I'm at the floor now. Now, listen to how much the engine is revving. I am coming up to speed, as you can see, but this isn't right, and I can see from my live data, does not look like I have boost. So this is acting like a naturally aspirated engine. I don't think I have plugged exhaust or anything, simply because the engine revs quite high, but it's not transferring any turbo boost. So let's do that again. Let me try and get a nice stretch here away from traffic. Alright, so I'm just going to take this bump here, and here we go. I'm on the floor. Look at the requested boost and what's actual. This car has no boost whatsoever. So that's an issue. And I am hearing a whistling sound coming from the hood. Sounds like we have a boost leak on this car. Alright, I accidentally kicked my dongle out. Now to try that again so that I can get a third capture. Make sure it is correct. So the road is clear ahead of me. And here we go. That's to the floor. Look how high my tach is going. And look at the boost that's specified. It's nowhere near what is actual. So we have a boost issue with this car. So let me turn here, and we're going to go back to the workshop and we're going to address this issue. All right, we have no boost from our data. before we address anything else like the mass airflow code we had, we need to find out why we do not have boost. I will tell you one thing. In the Kenyan market, any car that goes to a mechanic with no boost, 100% guaranteed they're going to put a turbo in this thing. Let me give you a word of advice. There are two items that should be the last on your mind, and you should do extensive testing before you replace them in engine diagnostics. The first one is an engine computer, and the second is a turbo. Highly likely you do not have an issue with one of those two things if you have engine problems. It is very unlikely. Turbos and engine computers do not go out often unless you're dealing with cheap aftermarket turbos. But OEM turbos, they hardly ever go out. So we're going to put a smoke machine on this thing, and we're going to smoke this intake and see if we have a boost leak, because it really sounded like we have a boost leak. Let me set my smoke machine up. All right, my smoke machine is going. We're going to pump smoke in the intake. Let me get a flashlight, and I'm just going to look around and see where the smoke comes out from. Do we have a boost leak, or do we have something else that's wrong with this engine? Let's see. Well, that didn't take long. Got a lot of smoke billowing from here. Let's see where it's coming from. And look at that. It's coming from the charge pipe. And that charge pipe doesn't look like it's in all the way. How about that? Okay, let's lift up this car and see. Am I missing a clip? I can't see whether I'm missing a clip, but definitely the charge pipe. I can't see any other traces of smoke. Looking up back here where the turbo is, that seems good. So for now, it's this charge pipe. So let's take care of that, and then we're going to smoke again and see if we have another leak. All right, here we go. This looks like it's operator error. This clip is not in its groove. So let's remove that. Remove our pipe. The O-ring appears to be in good shape. Okay, set that to the side. There's a slit here, and there's one on the opposite side, and that's where your retaining ring gets in. So let's put it in. So there you see it has come out, and on the opposite side you have that. Now on the charge pipe you've got this dimple here and a similar one on the other side. Those ones are the ones that are supposed to be retained over there. So with our clip in place, you just press in. There we go. It'll click in, and now we are secured. That's going nowhere. So I'm just going to clean this up some more, make sure there's no oil in our pipe, and then put back the smoke machine and test. Alright, our smoke machine is going, and now we are clean. No leak there whatsoever. Nice. Now let's go back to the car and see if this resolves our problem, but I think this is a fix. Alright, let's start the car. And we're going to see what our values are like. We're running on the Odis. And first, let me just accelerate real quick. And it's interesting now. I'm not accelerating as quick as before. I honestly can't explain what's going on there. Let's look at our live data. And on our live data now, it's interesting. Look at my mass airflow. You see how I've gone lower? Now we're at 2.8. We were at 3.5, sometimes hitting 5. That is so cool. We still have a lambda of 1. We've not gone to closed loop yet. Alright, so all this looks good so far, but we can only know when we go on a test drive. So let's go on a test drive and see if our issues have resolved. Alright, here I am on the open road. So let's get in here and get in it. And oh, whoa! I'm not even on the floor. Wow! Oh, that is a fix. This thing is powerful. Oh, let me do that again. Look at my boost. Look at that boost. That is excellent. I'm nowhere near the floor. So we are done. This is a fix. Okay. Let me pull to the side, put on my seatbelt, and we'll go back to the workshop and close this out. But I like this. This is excellent. Alright, we are back at the shop. This vehicle is doing very, very well. I need to erase that code. But first, let's take a quick last look at the live data. Several things to note here. Number one, notice that my long term is now negative 1.69, so it's tending towards 0. And my short term is hovering between negative 1 and positive 2. That's excellent. I've not seen that surge where it goes all the way negative as it was doing before. And look at our engine speed. Now we have dropped. We're at 720. And our mass airflow now has reduced. These are 2-liter engines, so we should be closer to 2 grams per second. These are very beautiful values. I like that. That is a fix. I just want to take a bit of time here and explain, because I'm sure some of you will wonder, how come it is that we had an air leak and yet we had a rich condition, and this car is now fixed and the rich condition has gone away, and all we did was to fix the air leak. So if you recall our codes that we pulled out of this engine, one of the codes was system too rich at idle. And when we were looking at our data, we had momentary bursts of time when we had the fuel trims go way negative. That's no longer an issue right now. So I want to explain that a bit. The problem is the way people understand fuel trim and oxygen sensors. We are never taught concepts and function and operation of stuff. What we are taught in classes is when you see this, you have this condition. When A happens, it must be B. I wish people would start teaching the concept of getting your fundamentals straight. If you understand basic concepts and how something works, then when you have a deviation from norm, you can be able to relate how that thing works, and then you can make a good decision. So let's talk about this. What tells the engine whether we are lean or rich? It's the oxygen sensor. And remember, the oxygen sensor only measures one thing: oxygen. Doesn't measure anything else. If your oxygen sensor sees a large amount of oxygen pass through it, the voltage goes down. If your oxygen sensor sees a small amount of oxygen or no oxygen pass through it, the voltage goes up. And the computer makes a decision based on that. So you've got to understand that the computer is making a decision based on what the oxygen sensor is telling it. When we have a rich condition, the computer sees the oxygen sensor activity and then it cuts down the amount of fuel going into the engine, thereby increasing the oxygen output, residual oxygen left over after combustion to go into the exhaust. So we need to understand that when we have a rich condition, it simply means we have very little oxygen going down into the exhaust. Remember, the oxygen is needed for the catalytic converter. You can't use up the whole thing on combustion. So the intention of the engine is to increase the amount of oxygen. So now we know we have a diminished amount of oxygen. Why is it then our boost leak caused that? This is a turbocharged engine. A turbocharged engine has a turbo, and our turbo sits just back here after this intake pipe. What is a turbo? A turbo is a compressor. And what does a compressor do? A compressor takes in fluid, compresses it, and then pushes it out under pressure on the other side. So you have the intake side, that is a vacuum which sucks in fluid. Then you have a chamber that compresses it. In our case, in our turbo, we have an impeller which causes a vortex. And then we have the outlet which has pressurized fluid coming out. Our fluid is air. So vacuum going in, pressure coming out. When we have suction going in, we have vacuum. What does that do? It causes it to read higher than when you have a naturally aspirated engine which doesn't have a turbo. So turbocharged engines will forcibly suck air in the intake. Now, that air goes in and it is pressurized on the other side. What does it do? It comes out, it goes down here, and it goes through the intercooler, which is behind our radiator. And then it comes out of the intercooler, and the intercooler, its role is just to cool the gases. And then that air comes here. The throttle body is over here. So you have pressurized air coming in, gets cooled, and then comes and waits here to be sucked into the intake. Now, what is between the throttle body and the intake is the throttle plate, and that throttle plate sits closed, okay? If that throttle plate sits closed, there is a bit of a gap on it, and that forced air is pushed into the intake, and the computer is calculated and tuned for that purpose. So when that blade is fully closed, it's not really completely 100% closed. Some bursts of air will push through that from the turbo, and that is calculated under normal circumstances on your computer's map. So that is normal. Now, something else happens when our throttle is closed. Remember, our car is not moving and we are at idle. Throttle is closed. So the pressure that comes out from the turbo is going to come here and it's going to pack on this side of the throttle, okay, of the throttle blade, on the pressure side, not the engine side, which is the vacuum side. When that happens, you have a resistance which forms back pressure and it slows down the turbo naturally. And that also slows down the impeller, which now slows down the air intake. Now, what happens when we have a boost leak? When we have a boost leak, we have air being sucked in, but it leaks out before it gets into the engine, so it's just leaking out. The turbo receives no resistance, so it gets its maximum pull here at idle, okay? So the amount of pull it has at idle, it gets its maximum pull, so it keeps pulling the air, and consequently, your airflow is going to be much higher. Remember, you're reading up to 5 grams per second instead of a normal 2.2 to 2.5 grams per second. That's because there is no resistance, so it keeps pulling, and that air is leaking out. But what happens in the computer's map is we are calculating fuel for 5 grams per second instead of 2 grams per second. It causes the computers to squat fuel expecting that amount of air inside there. But it doesn't see that amount of air. Why? Because half of it leaked out at our charge pipe. So when the air goes in, what happens? Combustion happens, and then the residual amount of oxygen that's supposed to be left over is completely used up. When those combustion gases goes out and they are measured at the oxygen sensor sees almost no oxygen, and therefore it feeds back to the computer. And what does the computer do? It tries to cut back the amount of fuel, not because of the air leak, but because it wants more oxygen down in the exhaust so that the catalytic converter is happy. It's all about the emissions. That is why we have a rich condition when we have a boost leak, and that is why this car is fixed with just fixing our boost leak. Now, the last thing is we also had a performance code for our mass airflow. And the reason is because that turbo kept pulling air with no resistance, the speed was higher than normal. This value was high. And the computer map knows that at idle, I'm supposed to have between 2 and 2.5 grams, and I was having up to 5 grams. So that range is exceeded, and what we get? We get the range code. Mass airflow range performance for that. Now, what would a regular mechanic do in this country? You take your car to them, they pull the codes, they see you've got a couple of codes. One of the codes is mass airflow range performance. What will they do? They'll replace the mass airflow. Then when they replace the mass airflow, they will still have that code. It will not fix it. Second thing they will do, go on a test drive, and then they'll see we have no boost. They will replace your turbo. You see how things will go to hell really quick? Guys, you need good diagnostics. And right here at K Mechanics, we know what we're doing, and we've given you the good diagnostics. Now, we have one more thing to tackle, and that is the parking brake. Let me just go first to the code and pull it up, and then I will tell you what's happening with this car. All right, this is the error she was talking about. You can see there's the P with the cross over there. And right now, the parking brake is on. But if you put the parking brake off, sometimes you still have that. So let me press the brake and put the parking brake off. Yeah, now you can see we still have that P with a cross. Now, when that happens, she says when she's driving, the car drags back, which is a sign that the parking brake is held. So let's go to the codes, and I'm going to show you what code this has. Then we're going to go to the wheel and see what's up there. Back in Otis, let's go to the parking brake. Control module OBD, DTC memory. And here we have left parking brake motor, tensioning force not reached. And right now it is active, so it's keeping that warning light on. So what is going on? If I actuate the parking brake, I can hear that the parking brake is actuating. So let's go remove the wheels at the back. We're going to put a current clamp on both parking brakes, that is on the left and on the right, and we're going to take a reading when we actuate the parking brake. All right, here we are on the right side. Wheel is removed and the car is on jack stands. And by the way, always use jack stands. I see people putting their car on hydraulic jacks and you just leave the hydraulic or the scissor jacks there. Trust me, one day you're going to hurt yourself severely if you do this often. Do not work under cars without jack stands. So we have the current clamp. I've peeled back the harness over here and I've put the current clamp on one of the wires, and we're going to do the same on the left side. Now let's go on the left side and see what's up there first. All right, here we are on the left side, and I put my current clamp there. But now, before we go far, I want you to notice this. This is a pigtail that has been spliced in here. So this looks like has been replaced, and they could not get the connector out, so they cut it and put a pigtail here. Well, is this our problem or not? Let's see. I don't think it is, because the code is for tensioning force, not circuit faults. So let's see what's happening with the current, and you're going to see something very interesting. Right, our current clamps are ready, scope is ready, and first let me show you my settings on the scope. So I've set up a trigger on channel A, and I've set it to single shot, and I'm triggering off of the current of channel A. Channel A is my right brake actuator, that's a good one, and then the left brake actuator is the suspect one. So when the current goes up, the brake will move forward. That means it'll apply. When the current goes down, the brake will move backwards. That means it'll unapply. So first the brake is going to move forward, because right now the brakes are open, so I'm triggering off here. So when the current goes up and it meets that trigger, it's going to draw on the screen until it reaches the end, and then it'll stop because it's on single shot. Okay, both at a 20 amp scale. Now let's go to the parking brake and actuate it. I'm going to put the key on. Key is on, and we step on the brake and put on the parking brake. Parking brake is on, and I want you to look at this. So what we have here, we have the current rise up, and then it comes back down, and then it ramps up like this. So when the motor begins to move, you have a current spike, which is normal, and then the motor moves in front, and then when the current starts going up, what is actually happening is the motor is compressing against the pad. So this is it compressing against the pad. So it compresses up until it reaches a certain amperage, which is in this case 15 amps. And when it reaches 15 amps, the computer knows we've reached home, and then it stops the actuation, and then it actuates just slightly again. I don't know why it does it a second time. So that is the working one. Now let's look at the suspect one. Right now, that motor appears to be working. You see, we've got the same thing, but then we've got this. Why do we have this? It looks like the motor got stuck here at a certain point, and then it started moving again, and then it reached its peak current, and then it was shut off. So this, apart from this, it actually is good. Now let us release the parking brake. So let me move my trigger from the positive to the negative here, start my scope, and let's come here, release. Let's look at the capture. And now let's move up here, and let's move this here. So to release, we just back it off, and again it's supposed to read the current going backwards. So right now this system looks like it's working fine, but I want to show you the failure. So let me actuate and deactuate. I'll actuate and deactuate until the failure occurs, and I'll show you on the screen what exactly is happening. Okay, I've actuated and deactuated a couple of times until my error has come. You can see that my error is there. Now let me put on the parking brake and listen to the right. It's still going, and look at what we have here. So we have on the left our turn on spike, which is normal. Our motor travels forward, starts encountering resistance on the pad, then reaches its 15 amp threshold, then it stops. But look what happens on the right. So we have the motor turn on as normal, and then when it starts going, it encounters some kind of resistance, then continues, then it starts compressing on the pad, but it doesn't compress that pad all the way. It reaches a point where it is just spinning and spinning and spinning and not moving forward anymore. And then you had the motor keep going, so it keeps going, and then it shuts off after some time. When it quits, it brings that error that the tensioning force is not sufficient. So we are done. We have a bad right actuator. Now that actuator has been changed, and I actually looked at the part number, and I can tell you the part number is not even the correct one for this car. It's for a Golf. It's not for a Tiguan. I'm going to go to the parts diagram, and I'm going to show you the part number that is for this car, and we're going to see the part number that is installed here. And we come back to the same thing I've been rapping all over and over again. Respect your bloody part numbers. Do not put random part numbers in cars. Just because they look the same doesn't mean they are the same. There's a reason why they are different. So check this out. This here, I don't think it is getting stuck. After seeing that part number is different, I think this motor is supposed to do something here that it's not doing, and over time it has damaged the motor, because this is quite intentional. Let me filter that. It's quite intentional how this goes here. So it looks like it's supposed to do something, and then it doesn't happen, and over time it has just been damaged. Right. So let's look at our part numbers, and then we are going to see what is installed here versus what it's supposed to be. Okay, we are here in Etka, and this is my parking brake here, number 2. And you can see servo motor for brake caliper housing with assembly parts, both for the left and right. It's the same part number, 3CO998281A. That's your part number. Let's go rip that out and read the part number from that unit. All right, brake actuator is removed, and that's my part number label. And most of it has been erased, but you can see this part number ends in 8229. So confirmed, we have the wrong part number installed. That's it for this 2013 Volkswagen Tiguan with its 3 problems. The first one was the battery. The second one was the charge pipe that was not installed correctly. And the third one is the wrong actuator being placed on the rear left side of the vehicle, causing a parking brake error. Respect your part numbers. All right, hope you've enjoyed that one. We'll see you next time.